This verse, Psalm 19:1, starts, "The heavens declare the glory of God," but it also continues on and says, "And the heavens are his handiwork." Literally, God put this together. And what you're going to see tonight is actually stunning. Always good to start in Genesis 1:1. In the beginning, God created the heavens and the earth. This speaks to the issue of time, space, and matter, all that is. There is no place that we can find in the universe that is not always time, space, and matter. You'll never find space and matter without time. As a matter of fact, they don't have any meaning in their definition. All three are always together. And so when God says in Romans 1 that man is without excuse, that you can tell about his eternal power and his Godhead by this construction of the universe, here's a perfect example. It's better than the egg. It's better than states of water, all examples that we've all used. But the universe itself is 3 in 1. And yet all three are different, yet all three are equally part of what it means to be. Creation ex nihilo, it's a Hebrew word. It means that by the word of God the heavens were made and all the host by the breath of his mouth. We need to start here because most of the night I'm going to be telling you a story about secularists and what they say has happened. But we need to stay grounded in the idea that God did this. He did it within the 6-day creation story, and he did it by his word, by the word of his mouth. For by him all things were created that are in heaven and are on the earth, visible and invisible, are their thrones, dominions, principalities, their powers. All things were created through him and for him. That is specifically speaking of Jesus Christ, the second person of the Trinity. Now, then God said, "Let there be light," and there was light. So I'm going to tell you a little bit about light, and then we'll come back to this. There are 7 properties of light. Light travels very fast. It has a dual nature, which we'll explain. It travels in straight lines. Light always travels in straight lines. Light can vary in intensity. It interacts with matter. Light's comprised of many colors, and it carries information and energy. So when we talk about light, that little colored thing in the middle, that's what we see. That's called the visible spectrum. Most of light is actually beyond that, either longer wavelengths or shorter wavelengths, infrared or ultraviolet. And we'll talk about all of that. But the electromagnetic spectrum, the wavelengths vary from subatomic particles up to buildings. Some wavelengths in the infrared are very long wavelengths. So light has a lot of variability to it. And across the entire spectrum, man has learned how to interpret the information that comes off of light. So wave properties of light, from the blue, which are longer wavelengths, to the red, which are shorter wavelengths. It's a great picture. That's actually a picture of a spectrograph of the wavelengths of light. And essentially, every color has its own wavelength. That's how light works. So light changes what color is displayed by the different frequency of the wave. Light also has reflection, absorption, transmitted abilities. I think everybody knows that a red color is just that the red is not being absorbed. All the other colors are being absorbed by whatever surface it hits, and only red comes off. So that's what we call red pigment, like in your shirt or whatnot. This is really, really important. Light needs no medium to travel through. Light is not dependent on water, it's not dependent on air, it's not dependent on space. Light is independent of all of those. It's called a transverse wave, which makes light something very, very unique and very special. So here's the idea of a longitudinal wave. So as I speak to you, that kind of wave, that's a longitudinal wave. If a bunch of wind comes by, you're not going to hear me because the wave can be disrupted by the wind. On the other hand, if I take a flashlight and I'm in the middle of that storm, the flashlight, the light is not affected by that wind at all. That's what a transverse wave is. It's very different. So light is independent of the environment around it. Polarization is essentially light has two axes. So there's one axis, I'll show you that in a minute, that's electromagnetic. The other is electricity. Magnetism on one and electricity on the other. So polarization is simply blotting out one of the axes in the light wave. This is electric and magnetic properties. So a wave of light actually, while it's doing this, it's also doing this. Both, all the time. So there's an electric field in a beam of light or a wave of light, and there's a magnetic field on the other axis. So particle-like properties of light. I have just gone through most of the wave properties of light, but light also exhibits particle properties. So there's a dualism, there's two natures to light at the same time. Beams of light, as opposed to the waves, are made up of particles. Therefore, light exerts pressure. That's what happens when you develop a laser, a strong one, and it starts cutting things. That's because that's the particle. That's not the wave part of light. That's the particle part of light. Light travels through a vacuum as well as through transparent media. Part of that is because it has particle properties. Beams of light are bent by gravity. So light itself goes straight. But the particles in the beam of light can be influenced by gravity. And this is going to be very important as we go into space, because there's something called gravitational lensing, where we're going to see a picture or whatnot, and that's light that's moving around a galaxy, literally moving around a galaxy and coming to us. So it becomes important that we understand light can bend. This was the proof that Eddington used in 1919 to prove Einstein's theory of relativity was right in 1915 when he published his second theory of relativity. The photoelectric effect, in other words, electrons are emitted from metallic surfaces. That's part of the particle property. It'll reflect on shiny surfaces, and different colors have different energy levels. This is why the application for blue lasers is different than green, is different than red, because they have very different properties as a result of the nature of the light color. This is important. Light is never acting like a wave and a particle at the same time. It acts as one or the other, and it can move back and forth very, very, very quickly. So, until I had the opportunity to study a little bit more about light, I thought DNA was the most elegant information system known that God made, because it's incredibly complex. I will say that light is on that scale. The amount of information in a wave/beam of light is stunning. We can pick up things by its frequency, its amplitude, its wavelength. We can pick up color and intensity, the direction, photoelectric effect, electric, magnetism, and polarization are all in a single beam wave of light. The amount of information that's there is stunning, and I'm going to show you the end result of that when man builds something like the James Webb, which is designed to interpret the light. So now, when you read this verse in Genesis 1:3, and God said, "Let there be light," you ought to think a little differently about it. It's not a simple thing. And further, the psalmist goes out to say, "You are clothed with splendor and majesty, covering yourself with light as a garment, stretching out the heavens as a tent." We're going to talk about that too, stretching out of the heavens. Because secular man denies that truth, he comes to a different truth about what we see up there, and we'll talk about that. So the Apostle John describes God as three different things. And his first one is God is light. He says God is spirit, and God is love. So I just want you to get the idea that this idea, God said, "Let there be light." When did he do that? Genesis 1. Genesis 1:3. It's the thing he did after he created the heavens and the earth, right? And then the Spirit is hovering over the face of the deep in Genesis 1:2. But it's one of the first things he did. It's all done on day one. Before anything else was, God made light. So light stands for a lot of things in Scripture. First off, it's God's covering, as we just read out of Psalm 104. It's God versus no God. It's light versus darkness, day versus night, truth versus untruth, right versus wrong, ignorance versus knowledge, understanding versus confusion, wisdom versus foolishness, and saved versus lost. And I'm sure I did not get them all. Okay. The idea here is light is just an incredibly important concept. It's introduced right at the beginning, and it has huge meaning to us. So the creation week, just to emphasize it, God creates time, space, matter, energy, and light on day one. So it's here right at the beginning. Before there's any sun or moon, I know the secularists laugh at us whenever we say that, where'd the light come from, right? And then God created the earth upon the waters and divided the water. So contrary to what the secularist tells us, the ocean was here first. The ocean was out in space and earth was put in it, and then God created the separation later. That's Psalm 24. God creates the heavens then, and then God creates the stars for purposes, to mark times and seasons. So where do you think those stars mark times and seasons? Why do we have seasons? We have seasons because we have people, right? It's inhabited. Otherwise, seasons don't mean anything. Season only means something if somebody's here to get it. We also have an axial tilt. We have a habitable planet. There's just a whole series of things that lead to that. So when he says he wanted to mark signs and seasons, he talks about the greater and the lesser light. We'll talk about that. This is really important. Day 4, he not only creates the stars, but then he stretches out the heavens. This is going to be very important because astronomers don't understand this. The astronomers and what you're reading in the paper says that as the Webb looks out farther and farther, that starlight is older and older. And what they are telling your kids and your grandkids is those farthest away galaxies are 13.1. That's only 700 million years after the Big Bang. And so that light is 13 billion years old. So if you don't understand that God made everything in a ball in the center, however he did it, and 9 times he tells us he stretched it out. And so as a result, we believe that just like Adam and Eve were born mature, so mature starlight comes to us in that way. But they do think you're crazy if you don't believe that that's looking back in time. Then he creates man. He creates God with the amazing animals. That's a talk at Brookside Baptist Church in November for this group, the amazing animals. So we've got the sun and we've got the earth moon. God made the 2 lights, the greater light to rule the day, the lesser night to rule the night. Look at that next phrase. He made the stars also. You understand it's an afterthought. The point is the greater light, the lesser light. The point is earth. This drives secularists crazy, that there's anything special about earth, other than it's the only place in the known universe that supports life. And that's why they're trying so hard, and I'll show you how they're doing it, to demonstrate that life exists somewhere else, because they believe it's their ticket to the denial of God, which they're already doing. They believe it's their proof. So when we talk about the earth, just a couple of things that are really interesting about the earth. That's a picture of the sun moving in its orbit in the Milky Way. And we'll talk about that in a little bit. But the point is there's this huge, it's called a heliosheath on the front end. And we've had Voyager 1, Voyager 2. They were launched back in the 70s and the 80s. They're out there now. It took that long to get there. And they've given us a lot of readings. But the point is that the Earth is actually protected by our sun. Our sun puts out what's called a solar wind, and essentially creates a shield in front of us as the Earth, as part of the solar system, moves through the cosmos, because everything is moving. Everything is moving. The sun is circling something, our galaxy is circling something, we're circling something, the moon is, everything is circling something, right? And we're moving through space at an unbelievable speed. This is important. I made the earth to be inhabited. It's Isaiah 45:18. He says, I am the Lord, there is none other. He says, there's none like me. He says, I did not create the earth in vain, I created it to be inhabited. The information on that statement is just incredible because there is no place else. So when man wants to create a place where man can live that's not inhabitable, we build things like the space station. I didn't include those slides because it takes too long, but the idea is, do you have any idea how complicated it is? And you think the space station put itself together by accident? Well, that's the Earth and the universe. It's like a space station. It's the only place we can live. Plants, animals, all of us. Second thing is, we have this magnetic field. The magnetic field protects us against coronal mass ejections, as we used to call them solar flares from the sun. Solar flares are largely gamma radiation. Gamma radiation is absolutely, totally deadly to humans. You can stand 5 grays, that's it. It's a small amount of radiation, gamma radiation. So without the magnetic field, every time a solar flare comes towards Earth, which is usually about once a month, everything on Earth would die if we did not have the magnetic shield. The other rocky planets on the inner don't have that. So there's a promise in Scripture. If the heaven above can be measured and the foundations of the earth searched out beneath, I will cast off the seed of Israel. This seems amazingly poignant given the circumstance right now. But I will cast off the seed of Israel for all that they have done. What God is saying through the prophet Jeremiah there is, you will not find the foundations of the earth. You will not be able to count the number of the stars, because I have made this eternal promise to Israel, and I will not go against that. And that's told to us, and the Lord, He is the one who goes before you. He will be with you. He will not leave you nor forsake you, not to fear or be dismayed. The idea is that God has given us this promise, in particular Israel, and they are not to be afraid as they move forward. He's with them. So now we're going to get to secular history. Essentially, they believe in this thing called the Big Bang, which, by the way, was a derogatory term by Sir Frederick Hoyle, who was the guy who was a big champion of the steady-state theory. Steady-state theory also denies God's involvement because it says the universe is eternal. The universe has been here all the time, and that it constantly goes through times of expansion, which is what they believe now, and contraction. So sometimes it's referred to as the yo-yo theory. The yo-yo theory was replaced by the Big Bang. So the Big Bang says it doesn't come back in, it just goes out. Okay? So from the Big Bang, the stars and the sun form. I think most of you probably know, but they are not trying to say that we came from apes anymore. They go way back, and we all came from stardust. That's because stars have the same composition as our bodies. Hydrogen is the most common element in the universe. But by that thinking, you could have come from your tire, too, because it has some of the same chemicals in it that you do. But that's the nature of the thinking, and that's what they're teaching, that your kids are from stardust. And then ultimately we get the Earth and the Moon. Finally we get dry land after a very long period of time, hundreds of millions of years. And then we get this evolution of life. So this is what they're essentially starting with. So what are their proof? This is an ancient meteorite. It's a piece of Erdchek 002. It's a large piece of embedded pyroxene crystal. And essentially, I want you to read what they're saying. This is right out of the high school textbook. That the rare object, second bullet point, known as Erdchek 002, and an isotope contained with it suggests a sprinkling of radioactive material from recently exploded stars I'd love to meet the scientist that knows about recently exploded stars. Infused with our solar system towards the end of its formation. Now, I don't know about you, but I don't know anybody who was anywhere near here when our solar system was formed. So think about that. So they find this crystal, you can see it in the middle there, on a piece of the rock, and from it they conclude the sun, like all stars, was born from gas and dust. The solar nebula was a dense cloud floating in space with a denser region that would collapse under gravity to form a baby star, spooling in more and more material as it spun and grew. Once the sun had swallowed its fill. Let me say that again. Once the sun had swallowed its fill. This is the personification of nature. They are doing this constantly. God's will, God's purposes are being replaced, and nature itself has a goal. Evolution itself has a goal. Stars don't seek out their fill. Stars don't seek out anything. They are physical phenomena, and they are not in control of what they do, and they don't think about what they're doing, etc. This personification is being done through cartoons, through some of the famous places. I love cartoons, but I have to tell you, they've been turned into a very evil propaganda machine for the secularists. All this personification of Mickey Mouse and all of the rest of them, at the end of the day, leads to this kind of discussion, and this is all the time. So they're saying this is proof about the fact that we came from stars. Somebody found a rock with some crystals in it, and they tell a great story. So, how old do they say they are? The universe, 13.77 billion. The Milky Way, 13.2. So we're early. Yet, we're not too close to the beginning, right? We're arguably looking at stars, by the way, in every direction at about 13.7 billion light years. Where are you if when you look out, the farthest horizon is the same in every direction? Where are you? You're in the center. Wow, that drives secularists crazy. Then you're some kind of heliocentric nut, right? So at the end of the day, just understand, we think we're in a gravity well because of that. But the solar system is 4.5 billion years old, and then our sun, 4.6 billion years old. So this is a picture, when you talk about the Big Bang, of what they're talking about. And you start from a singularity. So their argument is the universe always existed. Again, they replace God. The characteristic of God of being eternal. God says in the beginning, He created the heavens and the earth out of nothing. That's not what secularists say. There's a singularity. I can't explain a singularity except that the entire universe was in a point, as small as the head of a pin, smaller actually, and it suddenly started expanding. They don't like the term Big Bang, but it started expanding, the expansion. That's what they're showing here. They call it inflation. And there's the quantum fluctuations, etc. And then there's this afterglow, which is about 375,000 years after this started. So if we look at Scripture, we have day 1 here, and we have day 4. That's about 400 million years for them. And at the end of the day, we have this whole area out on the end called dark energy, dark matter. And we'll talk about that over the course of the evening, but I'll show you why we need those things. This is called the background radiation. The argument is this is the leftover, this is the residue from this enormous Big Bang. So this is radiation, and it's diffused throughout wherever we look, we see it. That's an actual map of when we look out from here, we would be in the center. That's an actual map of the level of intensity of this background radiation. It's out there. But what this proved was that what you and I can see is only 4.6% of what needs to be there. So basically, this was found out probably 30, 40 years ago. In the solar system, we all know that Mercury kind of goes at a fast pace around the sun. And as a matter of fact, gravity is so great, Mercury only shows the same side to the sun always. Right? There's a dark side of Mercury that has never seen the sun. Just like we have a moon. Our gravity holds the moon in stasis. The moon goes around us, but you're seeing the same surface all the time. When they say the dark side of the moon, they're saying the part you've never seen, except for when we put spacecraft up there and take pictures. Okay? So, but what I'm getting to here is something called Coriolis effect. So essentially, Pluto is going much smaller. Let me come back in and go to Neptune, right? Because Pluto is not a real planet anymore. So the point is that in the solar system, the closer you are to the sun or the source of the gravity, the faster the body will move. You got that? Have you ever been in the airport or one of these places where you take a penny and you put it in that thing and it goes around and around and around down the hole? The closer it gets to the hole, that's the closer it is to the source of gravity, the faster the penny moves. That's how our solar system works. Mercury moves much faster because it's under much more pressure from the gravity of the sun than Neptune or Uranus is. The galaxies don't work that way. So if the angular momentum, if the reason everything is spinning is gravity, and the outside arm, there's 6 arms to the Milky Way, we're between 4 and 5. If the outside arm if those stars are moving at the same rate as the inner, and the black hole at the center is supposed to be the gravity source, that should be moving much slower, but they're not. So there's a need for an enormous, and I mean an enormous, amount of additional matter to create the energy of gravity to make those outer stars move fast. And all galaxies do this. So gravity works at a different level on the galaxy level than it does on the solar system level. So as a result, we're called baryonic matter. Baryonic matter is atoms. This is what we typically thought of as atoms. This is the part we see. So when we measure the volume of all the stars, the planet, everything we see, quasars, everything, we can only account for 4.6% of the matter to generate the gravity to make the universe move the way it does. So you need to understand this theory is thin, real thin. So we have things called dark matter and dark energy. And that makes up the other part. And so we're going to talk about that a little bit. But the visible universe is about 5% of what we see. There needs to be a lot more matter somewhere. Now we know that the universe is held together, literally consists in Him. Hebrews tells us that the universe consists in God. And so we don't know what God's doing to hold it together, but I can tell you the secularists don't have a clue. So, atoms, things that we think of as atoms. And atoms, by the way, aren't what you or I were taught. Atoms, we used to think of a nucleus surrounded by some electrons, right? But today we know that there's hadrons, leptons, bosons, quarks. You know, it turns out that a proton is made of 3 quarks, 2 positive, 1 negative. That's why it has a positive charge. Neutron is 2 negative quarks and a positive quark. That makes it neutral with everything else. So the standard model of elementary particles has changed dramatically. So we thought we understood it, but we didn't. Didn't understand it at all. And so we've got quarks and leptons, and we've got 2 kinds of bosons. Bosons we can't even see. Bosons are carriers of energy. They're action things. They're not physical matter. They're rather methods of transferring energy out of the atom. So at the end of the day, the point is, this represents about 5%. That's all it accounts for, is 5% of how the universe operates. So they have to go into dark matter and dark energy. So this was all the introduction. And I just wanted to finish with this. He counts the number of the stars. Remember before he says you'll never count them, ever. So any scientific endeavor to do that is kind of lost. I will tell you that we believe there are 50 trillion, that's not a mistake, trillions of stars. And the galaxies number in the billions. And I'm going to show you a 1% field. I'm going to show you deep field space where if you take a grain of sand, put it up here, that's the amount of space you're looking at. There are literally millions of galaxies, and it doesn't seem to matter where we do it. So when God says that you can tell his eternal power by what he's been made, and that the heavens declare the glory of God, it is beyond all understanding what's actually out there. And the secularists will say it's arrogant of us to think that we're special, right? Because there's all that out there. And because there's all that, there has to be life elsewhere. So we are spending billions and billions of dollars looking for life, and I'll take you through that too. So let's just start here, and this is the Tower of Babel from Genesis 11. The Lord said, "Indeed the people are one and they have one language," and this is what they begin to do. "Now nothing that they propose to do will be withheld from them." You are living proof of God's warning about this. Gene manipulation. There's an animal called a tardigrade. I told you you could survive 5 grays. A tardigrade can stand 5,000 grays. It also is impervious to DNA damage from radiation. It can live out into space. It's found everywhere, etc. This thing is really tough. So you know what we're doing with it? We're taking human T cells. We aren't. Chinese are. They're taking human T cells and they're using CRISPR technology. That's how they splice genetic material out of one of these tardigrades. These things, by the way, are microscopic. They're called moss piglets or moss bears. They're out in your backyard, in your lawn. And these things, they're taking that DNA and combining it with a human T cell. And in fact, the T cell becomes more resistant than typical human cells to radiation. So I can only tell you that's what they've admitted to doing. Okay? And you guys all know about the mRNA story as part of our vaccines. And this is turning out, my job is data, big data in healthcare. So I watch the stuff that's going on all over. I mean, trillions of transactions. And I can just tell you, mRNA, messing with it was probably not a good idea. The more we study, the worse it is. So we got fission. You know about that, right? We may get another test of the release of atomic weapons soon. Cloning. Cloning is DNA manipulation on a different level. And there's an assumption. There's an assumption with cloning. That assumption is that life comes from the mechanical part of reproducing DNA. There is nothing mechanical about life. Life comes from God. We can manipulate genes, but we don't control life. We don't even know what life is. So at the end of the day, this is another area that's incredibly dangerous. The idea that they can create a clone, they may be able to duplicate your cells, but create another you? I don't think so. And artificial intelligence. So some of the warnings you're hearing are worthy of discussion. Artificial intelligence can be a huge boon to human endeavor, but it can be just as dangerous. Like most technologies, it's going to depend how it's used. And the problem is when you have a culture, not just in America, but in a world that has no regard for God and thinks they're the be-all, end-all, at the end of the day, it's not a question of can we do it. The question is, should we do it? And if we do it, can we put it back in the bottle? And in general, so far, the answer is no. And I suspect if you ask the Chinese in the Wuhan lab, they couldn't put it back in the bottle once it got out, assuming that's true. So in Daniel 12, we're told, "You, Daniel, shut up the words and seal the book until the time of the end. Many shall run to and fro, and knowledge shall increase." So we know knowledge is going to have a huge increase whenever this time of the end is. And this revelation, this series of revelations that were given to Daniel, is to be opened up. Those books are to be opened up then. So let's just talk about that. The scientific understanding about 600 BC was based on physical world, right? What did we have? We had globes, sundials, armillaries, ories. These are mechanical structures trying to simulate, for instance, the movement of the planets around the sun, or a globe, right? How the land masses are distributed on the Earth, etc. That is what constituted the front edge of science. Now, they were pretty smart. Matter of fact, they just found a tablet with Pythagorean's theorem. Remember Pythagoras? A squared plus b squared equals c squared, right? The triangle. They found a tablet that's 1,000 years before Pythagoras that has that formula on it. So we don't know if he plagiarized or what, but scientific understanding today, computers and the internet, optical radio telescopes, particle accelerators, spacecraft and probe satellites. I mean, I just picked a few. You can see that this is about manipulation of time and space. It's not really about physical matter. So let's talk about the first Model T, 1908. Took 60 years from moving from horse and buggy into the first car. Took about 60 years to put a man on the moon. There's no other time in history that knowledge increased at that rate. There is nothing like the era you're living in. And if you think that's something, you should see what the technology is doing now, which I'm going to show you a little bit. So space exploration, if I go to space, I started with the horse and buggy in 1908. But if I want to go to space, I go to Sputnik in 1957. Took 12 years to go from the Russians to put a satellite in space to the Americans putting a man on the moon. 2, actually, right? And 1 more in the orbiter. So at the end of the day, this is an incredible increase in knowledge. And we're going to talk about that too. And NASA, all the spin-offs, there are 2,000 things we do, including materials science, all manner of medicine, etc., that were advanced because of this. So this was no different than war. You may have heard war is the mother of necessity, right? Because survival's at stake. A lot of technologies come up during war. They don't tend to be human-friendly technologies. They tend to be army-friendly technologies. But we were in a form of war when John F. Kennedy said, we're going to the moon, we're doing it, and they were afraid of the Russians. They literally were. And the amount of technology that came out of that, a lot of it was useful in consumer world, very useful. So I thought I'd talk about the Space Force for just a minute. And the reason I do that is there's 3 levels of orbits. When you talk about a satellite, it could be in low Earth orbit, medium, or high. The low Earth orbit is good for getting signals, sensing things, spying, things like that. Middle Earth is more about global positioning, navigation, things like that. So the GPS satellites will be in middle Earth orbit. And then the upper Earth is geostationary. This is when I don't need multiple satellites. So Elon Musk's satellite system, he's got thousands of them up there, and they're in low Earth orbit. But they're not connected to the internet unless you want them to be. And so this is how the Ukrainians have been fighting the war. Their information system is low Earth satellites, Elon Musk's system. And so now, since this was so successful, virtually all the countries want to do this. You have no idea what a jam up there is up in space. And then all of these satellites, they run out of power. Right? We don't go up there and put new batteries in them. You put some kind of nuclear reactor in it, it's good for 5 years, 7 years, 8 years, and then it's space junk. And so there's whole parts of the federal agency that just track space junk. And I got to tell you, it's crowded up there. It's getting very crowded up there. And we're going to have more and more things kind of crashing back to Earth over time here. But this is all about Space Force. And then the future of exploration, as you move in miles, human operations have gone out a couple 100,000 miles. The moon is 250,000 miles away, for instance. But our human exploration goes out farther because we can use tools. We can send robots, we can send drones, etc. And then robots, we can send even further out into the millions and millions of miles. The near-Earth asteroid is scheduled to be 2027. It'll be studied, and I think you know this, but we made a satellite and we crashed it on purpose into an asteroid who's close to the Earth. The idea was, can we change its trajectory? And the basic answer is no. Satellite's not big enough, going to have to be bigger than that. So the idea was, just like you see on TV, oh, this thing's coming right for Earth and we're going to blow it up with nuclear missiles and all that. It's a lot more complicated than that. This happens to be the Japanese Space Agency and what they're planning. So the Americans aren't the only space agency, or the Chinese or the Russians. This is the plan for the Japanese space exploration in 2035, and they're planning to literally put a colony on the moon. Not just send somebody to visit, a colony. This is the reason that they're looking for water, sulfur, and carbon on the moon, because these are the elements that will be necessary to create energy sources to sustain something up there, because we can't keep sending things up just to give them energy. They have to become self-sustaining. So hence the latest thing, this happened in August of this year. This is an Indian rocket, Indian. It's called Chandrayaan 3. It's India's third mission to the moon. They did, in fact, land a rover on the south pole of the moon. Mankind had never been there before. So a rover and a lander both explored the surface of the lunar south pole late this summer. So they were the fourth country to land a spacecraft on the moon. A couple of other countries have gotten up there, but they didn't successfully land. So this is an idea. We've, as humankind, have landed all over the moon. The Chinese are fascinated with the dark side of the moon, but none of the rest of us can see. That ought to scare you. And then India is down on the south side, southern pole. So, you know how we send a lot of work over to India because it's cheaper? So 6 Apollo missions, putting a man on the moon, cost us $25 billion. They just sent this latest mission up for $140 million. Now, there's a huge cost difference between, just machines and dealing with men or people. So I get that. But let's just say there's a magnitude of expense here that's going to be hard to sustain if our competitors are able to do some of this stuff for this kind of cost. So why look on the southern pole? Is a water resource, and they believe that in the shadows of the craters on the south side, which is closer to the dark side of the moon, there's a chance that there'll be water ice there. Turns out there is. Astronomical observation. One of the things for great observation is you have to darken the place that you're at. If you allow other light, that's like light pollution, and it interferes with the light that you're collecting from far away. So the south side of the moon is better. They're looking for more information about the rocks and the soil in that area, and they want to know about volcanic activity, and they did in fact find sulfur diffuse through the surface, which means the moon at one time had volcanic activity, because when it gets diffuse like that, it can't be from comets or meteors. You can get a spot that has that, around a crater or something, an impact crater. And the South Pole could serve as a potential base for human exploration. There's consistent sunlight for solar power. There's easy access to other resources, and it turns out that the south side of the moon is closest to Earth and has no dark periods for communication. So if you're going to set up a colony, that might be where you'd go. They discovered the presence of water molecules in the lunar soil, so of course you know the conclusion to that is evolution is true, right? Because when you look for a habitable planet, you have to find water that exists in the natural temperature range of that place. That's what's called habitability. And so if the moon has water, clearly that proves evolution is true. I'm being facetious, right? You understand that. But that's what they will say. We found water, therefore, water is the key to life. As soon as there's water, there's going to be life that's going to pop up in it. They've taken about 40,000 images. They found sulfur at the surface, and they detected a moonquake. Apparently the moon has earthquakes, or moonquakes, not earthquakes. And so Apollo detected some of these, and so did the Indian one. We don't know what causes them. We don't know anything about them. We just know they're there. This is called the iSpacecraft. It crashed in April of 2023. So this is a private Japanese citizen that sent this thing up there. And so when you got billionaires on the planet, and we got thousands of them, and you can send something like this up for $140 million, individuals so inclined can hire out everything they need. NASA doesn't do most of the launches anymore, right? These are private companies. And so you can do that. So the idea that we're told there's a time when knowledge will increase and people will be running to and fro, we seem to be in one of those times. I'm not saying it's the end times. I'm just saying, this is definitely an indication that knowledge is going up. So the United States, Russia, that's a Chinese rocket, and India are the four major space powers. But the CIA just published this summer an assessment of the space program for every country on Earth, and there's 90 of them. And the Chinese back about 20 of them. The European, Canada, and Japan are considered second tier at this point, but that doesn't mean they'll always be second tier. You're only one technology away from leapfrogging everybody else. This was a shock to me. So in 2028, this is going to be launched by the United Arab Emirates. And they're sending this space probe to the asteroid belt that's outside of Mars before Jupiter. And they want to find out the mineral content of the asteroids. They want to see if it's worth going there for rare earth minerals, things like that. This is the United Arab Emirates. So everybody's in space. So let's bring it back down to Earth and talk about space observatories. We have observatories. I showed you that spectrum of light. These observatories go along that whole spectrum. So we have observatories that are supposed to work right in the visible. The James Webb we're going to talk about tonight, the Hubble is in the visible spectrum. The James Webb is in the infrared spectrum. That's slightly longer wavelengths. There's a good reason for that. We'll talk about it. But we and everybody else out there is creating specific spacecraft to look at specific wavelengths of light. That's how much information is in light. This is the European Space Agency. They, like us, have applications across the spectrum and across the strata. Low Earth orbit, medium Earth orbit, high Earth orbit. So the European Space Agency is also out there in a very big way. So the Hubble telescope is the thing that kind of opened up the universe to us, in particular through something called a deep space image, or deep field image. It was the largest space telescope put in space. The Hubble orbits at about 320,000 miles. So the Hubble actually orbits the Earth, but it's farther away from us than the moon. The moon's 250,000 miles. The Hubble's outside of that, so that the Hubble can look at space without being interrupted by the Earth and the Moon, quite frankly. And it uses a whole series of what were state-of-the-art tools, and I think most of you may remember this story, that they sent it up there nearsighted. So there were 10 million lines of code used to polish the mirrors, these big mirrors. They're critical in the light collection. 1, 0 was a 1. It was off. 1. 10 million lines of code. Took them 6 months to find it. So the fix was to send the space shuttle up there, and they put something about the size of a silver dollar, and they put it on there, and it narrowed the Hubble field of what it could see, but it brought it into focus. So we essentially put glasses on the Hubble. But that was a very expensive mistake. They think about a $180 million mistake to put that little thing on there. So the Hubble telescope cost us $6 billion, and it changed everything we understood.